Let's discuss about universal set. Now, when you talk about universal set, see, universal set, a universe contains everything. Likewise, when we say universal set contains everything. Okay, whatever you take, a universal set has. Okay, if you take an example of real numbers contains everything, correct? Natural numbers, whole numbers, integers, rational numbers, irrational numbers. Take whatever you want. It is present in the set of real numbers. Correct? So a real number set is a universal set because it has everything. So generally, universal set is very subjective. Okay, now from mathematics point of view, especially from number system point of view, whenever we say universal set, it is the set of real numbers. That means generally U is the symbol what we use. U is equal to set of all real numbers. Now this is with respect to math, especially with respect to real numbers. Okay. Whereas when it comes to different scenarios, suppose if I say that, okay, now for human beings, suppose let's say, for human beings, when we talk about universal set, we consider the set of people in the world, everyone. Okay, everyone in the world. Fine. So this is how we, this is how we take the universal set as. It's very subjective. But the overall meaning remains the same because the overall meaning is what? Universal set should contain everything. That's why, depending on the what subject we are talking and discussing about, the universal set is going to behave that way. Okay, it's going to change each and everything. Fair enough? Now, this is another type of a set, a universal set. The next one is a very important thing, what we call as a subset. A subset is a very important part of a set. Okay, a subset is extremely important because most of the times when we define something, it is a subset. Okay, so whenever we talk about subset, now a subset is a part of a universal set. Okay, see, when I say universal set, it contains everything. So subset is a part of a universal set. So to give you an example, a set of natural numbers is a subset of real numbers. Okay, or you can say that set of integers is a subset of set of real numbers. Okay, now whenever we talk about some random set A being a subset of random set B, so we write it in this particular way. A is the subset of B. That symbol what you're looking at, like that C shaped symbol, this is the symbol to represent a subset. Okay, now what we mean by subset mathematically, that every element of A belongs to every element of B. Not every, as in it belongs to B. Okay, so mathematically how we define subset? A is a subset of B. This implies A which belongs to set A also belongs to set B. That means A belongs to A, which implies that A also belongs to B. That means every element in set A will be in set B. Okay, an example. Suppose when I say that set A is equal to 2, 3, 5. Suppose say set B is 2, 3, 4, 5, 6 and 7. Suppose when you take this, look at that, part of B is actually A, correct? That means 2 is here, 3 is here and 5 is here. Isn't it? So A is a subset of B. Now, but when we talk about subset, suppose if it's not a part of a subset. Okay, let's say in A only, suppose say I had another number 8, assume. Now A is not a subset of B. Then we represent it in this way. A It's not a subset of B. This is what we have. Okay, A is not a subset. Now that you have understood what is a subset, within subset only, there are different mathematical terms what we have. Okay, so let's discuss about these things. See here, suppose say set A. Okay, set A is, let's say, 2, 3, 4. Okay, and say set B is 2, 3, 4, 5. Let's take a simple example. Here, you know that A is a subset of B, correct? So B is called as superset. Okay, B is called as a superset. It's a very important term what we use. Okay, now especially in the set of number system, it's very, very important. Because see, when we talk about number system, the set of natural numbers, they are subset of whole numbers, correct? Natural numbers is 1, 2, 3, 4. Whole number starts with 0. And whole numbers, they are set of integers, correct? Plus, minus, plus, minus, plus, minus. And these are set of rational numbers, fractions, decimals. And they are subset of irrational numbers. So generally you can write it as T. T is irrational. And set of irrational numbers, they are the subset of real numbers. That means here, this real number is a universal set. Okay, universal set. All of them are subsets. But then if you take just the individual thing, in the sense, suppose if I'm going to take only these two, then W is what we call as a superset. Set of whole numbers, they are called as superset. R is the universal set because it contains everything. But between natural number and whole number is a superset, whereas natural number is a subset. Okay. Now, what if a set just has one element? Okay. For example, suppose when I write, let's say A is equal to X, such that X plus 1 is equal to 0. Now, X has only 1. In the sense, set A becomes minus 1. It has just one element, correct? Now, these type of sets are called as Singleton set. These are called as Singleton set. Okay, the reason is it has only one element. Now, Singleton set is a subset. Subset of what? A universal set. Depending on what your universal set is. Okay, so generally, a Singleton set is also a subset of depending on what you are looking at. Fair enough? So now that you have Singleton set, you have subsets and all, the next type of set is a very important one. We call it as power of a set. Power of a set in the sense what? Suppose say you have a set. We write all the types of subsets, or you can say all the number of subsets what we have for that particular set. Okay, let me explain what it is with an example. Suppose, let's say we are going to have, say A is equal to A, B. Two elements are there in the set. Let's try to write the number of subsets what we can write. Okay, I'm talking about the number of subsets. Okay, so first one is a null set 5, 1. Second one is just A. Next one is just B. The next one is A comma B. Correct? A comma B. A comma B. See, a set is a subset of itself because it has every element in it. So how many are there? So you get 4 in total. You have 1, 2, 3, 4. Correct? See, now we are calculating the number of subsets for a particular set. Correct? Now that is what we call as power of a set. Okay? The number of subsets for a particular set. That is what we call as power of a set. So generally, suppose if you have, let's say a set is A And in this, you have A, B, C, so on and so forth, till n number of elements. Remember, it has to be finite, definite. You cannot have infinite set. It has to be a finite set. Say there are n number of elements, then the total number of subsets or the power of a set becomes 2 to the power of n. Okay, for example, see in this one, there are 2 elements, 2 square, which is 4. So if you have n number of elements, then you are going to have 2 to the power of n subsets, what we call as the power of a set. And also keep this in mind that an empty set is also a subset and the set itself is also a subset. So both are subsets. Clear? So these are the types. Universal set contains everything. Subset, it's a part of it. It can be a subset, singleton, or it can say a superset, whatever it is. Okay, and then the power of a set, the number of subsets what you have in a set is basically power of a set. Clear? So in the next one, we are going to understand about different properties and different types of sets.